Artificial intelligence is everywhere. We can't really see it. More and more of us have heard about AI, but many of us can't really explain it that well. I have been involved in, no, make that immersed in AI for more than half of my life. As a roboticist that designs technology for humans, it kind of comes with the territory. AI is showing up in new technology products and services across every industry, which means actually we're all immersed in AI. So we probably should all understand it a little better. I've invited two of the world's leading artificial intelligence experts to join me for this episode to cover the ABCs of AI. Lucky for me, their offices are only a few hundred yards away. Welcome. I'm Ayanna Howard, Dean of Engineering at The Ohio State University, and this is Enginuity. Ohio State engineering professor DK Panda is a leader in the high-performance computing world. He and his team developed supercomputing software libraries that are being used by more than 3,000 organizations in 89 countries. He recently received the IEEE Computer Society's Charles Babbage Award, and for the last few months, he has been leading a National Science Foundation AI Institute called ICICLE, working to build a cyber infrastructure to make AI accessible to society. Also an Ohio State engineering professor, Ness Shroff is an IEEE Fellow and the Ohio Eminent Scholar of Networking and Communications. He's the editor-in-chief of the IEEE ACM Transactions on Networking Journal and has earned numerous awards for his work, including the prestigious IEEE Infocom Achievement Award. He too leads an NSF AI Institute called AI Edge to design the next generation of networks to optimize AI. Yes, you heard that right. 2 NSF AI Institutes are now based at The Ohio State University. You probably know that OHIO is a popular call and response cheer for Buckeye fans around the world. But I'm thinking OHAI has a nice ring to it too. Ness, DK, thank you for joining us.
Thank you.
Thank you. Thank you for inviting us here.
So, this is one of my favorite topics. And as I said in the intro, artificial intelligence, AI, intelligent systems, is a familiar term now. But ask 10 different people and you'll likely get 15 different definitions. So give me your definitions of AI, and then of course I'll share mine.
From my side, if you just take a look at artificial intelligence, intelligence can be broken down into two things, like learning and then making some decisions. So this is what our normal brains do all the time. But now through the AI, we're trying to do whether any other part of the machines, it could be a supercomputer, it could be even a single machine, or even it could be some devices, can they actually learn on a continuous basis from an external world and try to take decisions, and that too in an intelligent manner. And not only these devices or these machines can do these things, but can they also help human beings? I think that's how I see this field of the AI, which is becoming more and more important.
And so Ness, your definition?
I think, DK summed it up quite well. AI, the way I look at it is, traditionally thought of as intelligence that can be demonstrated by machines, rather than the natural intelligence that occurs in humans. The basic idea of AI, the way I see it, is that these machines learn from their environment, learn from interactions with each other in order to make decisions to optimize some goal. Now, this goal could be the betterment of humanity. This goal could be the improvement of some task, this goal, as in your case, could be to make sure that the robot picks up the ice cream instead of somebody's arm, right? So these are all kinds of decisions that these machines need to make, and they need to make them in an intelligent way, unlike the machines of the past, where the outcomes were somewhat predefined. And that's where the artificial intelligence comes into play. So the machine is learning as it's making these decisions.
So even though you two had slightly different definitions, there was some commonality. So there was the learning, there was decision making, there was improvement helping, and most important, there was humans, which is great. So the US government also understands the importance of this AI, artificial intelligence, and its potential to strengthen the economy and bring benefits to society for decades and decades to come. In 2020, the NSF launched the National AI Research Institutes, hubs for academia, industry, and government to accelerate discovery and innovation in AI. Last summer, as I mentioned, Ohio State became home of 2 such hubs. So DK, let's start with the one you lead, the AI Institute for Intelligent Cyberinfrastructure with Computational Learning in the Environment. Okay, so they say that 5 times fast. So for this conversation, I know the acronym for this is ICICLE. So what problem are you and your collaborators targeting it, and how can ICICLE design a solution?
Yes, so thanks again for mentioning that we got this award. Of course, there is a lot of challenges here. So to summarize, let me give a very small example which will illustrate the meaning. Let's take a farmer in the morning is trying to take a decision whether to harvest the crop or not. Of course, there is a lot of background information takes place there, and seasoned farmers, they know exactly what to do. But if somebody is also new, or even a season is changing, weather is changing, behind the scene, you need to make a lot of decisions saying, is the weather forecasting is good for the next 24 hours or 48 hours? If I harvest the crop, will I be able to sell it in the market with a good price or not? And if I harvest the crops, are there supply logistics available to transport it to the next place where it wants to be sold? So like this, some 10 or 20 of these questions you need to answer. So currently, of course, the farmers, they have a lot of data bookkeeping they have to do. They have to learn over the years. But the challenge is, can machines take care of this? Can the machines learn from this process and also help this person as the fingertip, just like our iPhone? You just ask a question. Even we are trying to support conversational AI, so the person who doesn't have to really type in the computer, just ask a question like Siri, ask the question saying, should I harvest it? And behind the scene, all these kind of operations will take place. It has to go and get the weather forecasting data, the supply data, market data, and then try to do the analysis. And not only for that area, but it can also use the knowledge from some other areas. What has happened in the last 48 hours? What has happened in the last 72 hours in that region or other regions, and give a good advice. This is a monumental task. And what we want to achieve is to make it very easier. Our slogan is actually plug and play AI. So all these different components we want to design, whether it's a hardware component or a software component or a middleware component, we actually want to standardize these so that all these components can plug and play and help common people like this. So this is just one example. We have 2 other examples, like a smart food set. Also, the 3rd example is animal ecology. So these are our 3 representative examples, and where we want to really study and investigate these problems and come up with a intelligent software. That's what we call it, like a intelligent cyber infrastructure, or ICICLE.
So you mentioned making it easier, plug and play, standardizing. It really sounds like you're democratizing AI.
That's exactly. That is exactly actually our one of the slogan, saying we want to democratize AI. So just think of what has happened to the power, like the electric power. 200 years back, it was a novel concept, but nowadays everything is granted. If I carry my iPhone and try to plug it in a plug, I expect it to work. And that's what we want to do to the AI components. So currently they are not standardized, they are bits and pieces, and somebody has to spend sometimes even days or weeks to make things work. And we want to put them all together in a very streamlined fashion so that any common man should be able to get benefited, or first use it and get benefited in whatever form. So that's how we want to democratize AI.
So I love this. Days and weeks converted to hours.
Hours, sometimes minutes or seconds. That is our goal.
Beautiful. So Ness, engineers and computer scientists, we love our acronyms. And you lead the AI Institute for Future Edge Networks and Distributed Intelligence, our AI Edge. So I'm hearing the marriage of AI and edge networking in the title. Perhaps you can explain this edge networking to our listeners first, and then describe how this institute will leverage the combination.
Right. So I'll start with the geeky version, and then, I'll get to sort of the more accessible version. So the formal definition of edge, the way you might want to think about it, is corresponds to everything that happens outside of the core of the internet. The core of the internet is essentially where you have these very, very high speed switches that are moving data at hundreds of gigabits per second from input to output. But outside of that is where the real action happens, because outside of that we have devices like all of your wireless networks, all of your wireless connectivity, your phones, your home computers, your laptops, but also things like computers in your car, computers in your farm, computers on street lights, on drones, basically anything that you can think of that has a wireless connection. And even most devices that have wireline connections are part of the edge of the network. And one of the reasons why the AI Institute that we lead focuses on the edge is because this is where most of the growth is expected. With this explosion of what we call Internet of Things, of devices that is about to happen, this is an area which is ripe for innovation. And we can make them, we can create new standards because we don't have to worry about, legacy issues. These are sort of things which, service providers or switch manufacturers might make us very hard to change. We don't have to worry about these things because these are all domains where new things are happening. And so this is sort of the reason for the focus on edge, and that sort of talks about what an edge network really is. Now, our institute really came about because of what we identified was a very critical need in the United States. So as your listeners probably know, if you look at networking and if you look at AI, these are two of the most important information technologies. This is for national economic competitiveness, national economic growth, national defense, national security. But while the US really has been the pioneer of both of these technologies, what's happened recently is that the US has lost their edge. There have been significant investments that have happened across the world, especially in what is known as the 5G wireless space, which has threatened our leadership. So the overall goal of this institute is really to correct this issue by developing not only a research environment, but also an education and a workforce development environment to retake US preeminentship in these areas of national importance. So if I can sort of elaborate a little bit more, the Institute focuses on two broad aspects from a research point of view. One of them is the development of what we call an intelligent plane that will allow future networks to essentially become self-optimized. That means they can reconfigure and find what the best solution for them is. They become self-healing, fully secure, and also efficient enough to be able to transmit information at very, very high speeds and very low latencies to meet various application needs. So these could be applications like autonomous driving, intelligent healthcare, holographic communications. all of this. But here, the big challenge that we have is that we simply can't use existing AI to solve these problems, because the networks are a very different beast from what traditional AI has been looked at. So we need to develop new AI in order to facilitate that. So that's one direction, one mission of the Institute. The other mission of the Institute is to enable distributed AI. And here again, because of the growth of the edge applications, we believe that distributed AI really is the future of AI. And the question is, can we develop network-aware AI algorithms and AI-aware network algorithms that will finally able to solve, these distributed AI problems that have been very, very hard to solve for many, many decades to come. So that's a big challenge that we have. Now, here, I sort of want to tie it back to what you and DK said earlier, which was about democratizing AI. So if you think about distributed AI, right now, DK has his phone out. AI is probably running on some of his applications, but they are running independently of everything else. Now, if DK is a very wealthy company, he could potentially connect to a cluster elsewhere and interact with the cluster in order to make that AI application that runs on his phone work really, really well. What we want to do is to remove that requirement. We want DK's end user application connect with mine or someone else in a distributed way in order to fulfill the full potential of distributed AI. So that's the overall goal of the Institute.
Okay, so one of the things you mentioned, it actually links to one of my favorite movies. So you talked about distributed AI, network-aware AI, holographic communications, machines and humans on the edge. The U.S. lost its edge. This reminds me flashbacks of The Matrix.
Yes.
All right, so if we think about The Matrix, one of the key things was, whatever you think, it's actually one of my favorite movies, but humans and machines worked in collaboration. So let's talk about collaboration in our present day. So collaboration, as you know, is always important in these NSF-funded endeavors, in research in general. But especially with respect to these AI institutes, when you're thinking about democratizing and providing a competitive edge in workforce development. So just to give our listeners an idea of the vastness of expertise you're tapping into, can you both list your partners?
Yeah.
Ness, you want to start?
Sure. So we have 11 university partners. As you know, Ohio State is the lead. And in the Midwest, we have OSU, Michigan, Purdue, the University of Illinois, Urbana-Champaign, University of Illinois, Chicago, as well as the University of Wisconsin. Now, if you move east, we have Carnegie Mellon, Northeastern, and UMass Amherst. And then moving westward towards the south, we have UT Austin, and then University of Washington all the way on the West Coast. In addition to our university partners, we started out with 4 companies in the project. 2 of them were AI-related, Microsoft Research and IBM, and 2 communication and networking companies. That's AT&T and Qualcomm. And we are currently in discussion with several large and small companies in order to establish new partnerships. In addition to university and industry, we also have top researchers from our DoD labs. So we have all 3 divisions represented. We have the Army Research Lab, the Naval Research Lab, and the Air Force Research Lab on our teams, so that any product that we develop as part of AI Edge, can be used by our U.S. DoD labs as well.
So basically, if you haven't heard of AI Edge in a few years, you probably do live in the Matrix.
That's right.
So DK, what about you? What are your
Yeah,
partners?
same thing. Of course, OSU, within OSU, we have a talented set of people, but when you try to take care of the responsibilities of all these bigger challenges, we have to have the right partners. So we also have like around 12 universities coast to coast, even starting from within Ohio to Ohio Supercomputer Center to Case Western. Going into the Midwest, we have the Indiana, Iowa State, and then on the East Coast, we have RPI, University of Delaware, and upper Midwest, we have the University of Wisconsin, and then going down, we have to the west, we have University of Utah, University of California, Davis, University of California, San Diego, and we also have two major supercomputing centers, San Diego Supercomputing Center, and then Texas Advanced Computer Center, and we have a company which is IC Foods, who works very closely with UC Davis.
But you're basically covering
The
the whole
from
United States.
The whole United States, from east to west. But in addition to that, these are our joint partners, but we have a lot of collaborators, just like Ness indicated. We have all major national labs, DOE national labs. We also have partnered with a lot of AI institutions which already exist from the previous grants. We will be collaborating with them, and also a ton of industries. So almost like 31 organizations who are our collaborators, including some DOE funding agencies, the federal agencies, kind of things. And we also have some international collaborators from Europe. And we hope that gradually we'll be expanding and working on these collaborators, and more organizations will be on board as we move ahead.
So with all these collaborations and these tendrils, I mean, it's just another reminder of why research universities like Ohio State are so vital to society and our economy. I mean, we really do know how to reach out beyond the borders of our buildings. So both of these AI institutes received $20 million in funding over 5 years. What will success look like in 2026 for both of you? DK?
Yeah, I mean, so, by the way, 2026 is not very far away, okay? We are already in 2022, okay? Even though we got funded last year. But our vision is, like, as I said, the plug and play, democratized AI. We have identified these three verticals, like I indicated, the digital agriculture, animal ecology, and smart food sets. At least we want to make a big impact in at least in these three fields. So this is where the idea is that we establish some kind of a virtuous cycle. That means we computer scientists will be actually working with all our partners along these areas, so that the development of the AI, whatever the solutions we use, will actually influence their field. And also we want to utilize so that not only they will be able to make progress, that will lead to bigger challenges, and that will come back to us. So that is the kind of the main virtuous cycle we want to establish, so that in 5 years, by 2026, I gave that broad vision of the farmer. If we can establish or demonstrate that a farmer is able to really utilize our AIs, and we are able to extend help to a farmer, like in any rural area, in any part of the country, I think that will be a big achievement for us.
Which is beautiful. You know, one of the things is most people don't know is The Ohio State started with the two colleges of ag and engineering. And so this is definitely appropriate in terms of expanding our footprint. So Ness.
Yes, so I mean, I think that success for AI Edge will take place in many, many different forms. From a research point of view, we hope to not only have many outstanding contributions in the traditional sense, papers, commercialization, etc., but we also want to move the needle on how distributed intelligence can really play a role in designing future generation networks and have it really adopted widely across the world in terms of standards by industry and DoD. Another very important aspect of our mission is to provide the tools and techniques needed to train an ethical, diverse, and competent workforce that will happen at the intersection of both AI and networks. And finally, I want to echo what DK said, which is this idea of a virtuous cycle. This is very much part and parcel of what we plan to do, which is that any research that we develop, we will accelerate its process into the implementation stage, into commercialization, so that we can get the right feedback in order to do appropriate research that can have real value to our end users.
So this is beautiful. A virtual cycle that includes AI and humans, humans and AI and humans all bundled together. It's just so wonderful. Well, it's obvious that the potential of artificial intelligence will, of course, rely on human intelligence. But the power and the impact that AI will have on the future is immense. And as we heard today, it will require infrastructure, tools, and policies to allow more than just a select few to use AI to solve problems around the world. I appreciate Professors Panda and Shroff joining us today for this episode of Enginuity. If you like what you heard and are interested in learning more or suggesting your own topics, be sure to connect with us on Twitter or Facebook at OSU Engineering. Thanks for listening.